So you've all just set up your practicals. Let's record some of the initial observations that we had. So what were the initial observations that you had for zinc? Lustrous, okay. What color was it? Grey or silver? Okay, I'm going to record silver grey here. It had a luster and was silver grey. What about copper? Someone help me out. Bronze in color. Did it have a luster?
Yes.
And it had a luster. Great. Magnesium, please. Silver in color. Did it have a luster? Great. Lead. Dark grey. And instead of luster, it was dull. Iron. Iron? Grey. And was there a luster or was it dull? Now, when it comes to our solutions, aluminium nitrate, what was the appearance of this solution? Colorless? Okay. What about silver nitrate? Colorless. And finally, copper sulfate. What kind of blue? Describe it. Okay. Light blue, transparent. And what I'll add for all of these now is solution, solution, solution. You could say liquid. Okay, I would be happy with that. So, when we're talking, your observations will be the next lesson, but here's what I need everyone to do right now. Can you make sure that your booklet is now on page 32? I want to see all laptops closed. I want to see everyone paying attention. So laptops closed, please. Thank you. Okay. So you are going to need in front of you your green chemistry data sheet. And the reason that we need our green chemistry data sheet in front of us is it has the standard reduction table on it. Now, the standard reduction table is your cheat sheet. Without your cheat sheet, you are going to have a very difficult time with these ones here. So in our first instance, in our first standard reduction, we have a combination of lead nitrate and zinc metal. Now, what we're going to do is in a displacement reaction, we need to determine if a reaction has happened to start. So we can see lead is in the form of lead nitrate. Is that a metal or is that going to be a solution or an ionic compound of some sort? Solution. So when we're looking at lead, is it lead as a metal or lead as an ion? So we can write below lead that it's going to be Pb and then nitrate is NO3. Now in order to balance this, what is the charge on lead? +2. Nitrate is 1-. So we're actually going to need 2 lots of nitrate. Zinc metal, on the other hand, is this a metal or an ion? A metal. So we can just write Zn. It's fine by itself. It's stable right now. So here's what you're going to do. You're going to go to your standard reduction table and you are going to find lead as an ion and zinc as a metal. So I'm going to jump back to my previous lesson here. So lead as an ion and zinc as a metal. So zinc as a metal, I'll circle over on the right. Lead as an ion, I'll circle over on the left. Now, if I have a look, here, you will see that lead as an ion is above, okay? So my left hand is above zinc, and this means that there will be a reaction. And what happens in this reaction is as follows. In the case of this one here, our metals swap place, okay? So lead and zinc swap place. So we're going to end up with the following. Number 1, we are going to end up with, I'll draw my arrow in here and I'll represent it as a different color. I'm going to have zinc which has a charge of +2, nitrate. Notice now, again, how the zinc metal has swapped place. It is now a part of that compound. Now, in order to make it balance, again, we need the 2 there to make sure our charges equal 0. Once we've figured out zinc nitrate, we're also left with our remaining metal. And our remaining metal that's left over, that has been displaced, is lead, Pb. So when I write this formula above, okay, you will see that it is now lead nitrate plus zinc metal produces zinc nitrate. And what? And lead metal. Now, this one, we write out in full because there was a reaction, because our left hand was above our right hand. So what we're going to do now is we're going to repeat this displacement reaction, and we're going to do 2 more examples together. Yeah, question?
When the first ones,
yes.
or like the ones with the other element, are they always going to be iron?
Yes, that's right. And that's your way to identify it. If you see whatever metal, that is going to say to you that is the metal, and whatever it's reacting with is your solution. Okay? So when we talk about calcium chloride, we're going to start by writing it out as a formula. So calcium is Ca, chloride is Cl. Calcium has a charge of +2, chloride has a charge of -1. So to make this equal 0 for our charge, it is CaCl2. We add that to magnesium metal, Mg. Mg just by itself. Now what I'm going to do is I'm going to highlight again, and I'm going to show magnesium metal in green, and I'm going to show calcium, the metal from calcium chloride, as just that Ca highlighted. What we now do, we go to our standard reductions table and we're looking for calcium ion and magnesium metal. So I jump back to our previous lesson, calcium ion, magnesium metal. So number 1, calcium ion over on the left, magnesium metal over on the right. Now they're right next to one another, but in this case, is my left hand above my right hand? No. So in this instance, you're going to love this because it's easy marks for you. There is going to be no reaction.
We have to draw the arrow?
Nope, you can just write no reaction and you will get full marks.
If we already drew the arrow, would you lose marks?
No. But you can just write no reaction because no reaction takes place. Yes?
Do you have to do the first part of the equation?
No, you don't have to. The only reason that I've written this one out here is to make it really clear when we go to the standard reduction table what we're doing. Okay? So you do not need to write out the first bit like we did here for ones where no reaction takes place. However, for me, this is a little bit of my working out to help show that process. So let's have a look at one final one together. So again,
You don't write anything at the top and there's
no, there's no reaction, so nothing's going to form. It's like adding these 2 things together and nothing happens. Okay? Now, silver nitrate and aluminium metal. So again, silver is our metal here, aluminium, our metal on the other side. When we talk about silver, silver is Ag, it has a charge of +1. Nitrate, NO3, has a charge of -1. They are balanced. We add that to aluminium metal, Al. Again, our next step becomes going and having a look for silver ion and aluminium metal. So I go back to my standard reduction table and I'm looking for silver ion, and I'm looking over on my left-hand side, right at the top. And what was the metal again? Sorry, magnesium? Aluminium. Aluminium metal. Silver ion, aluminium metal. Is my left hand above my right? Yes. So a reaction takes place. And I jump over to my equation here, and now I can use my blue pen once more. All that happens when there is a reaction is that the silver and the aluminium swap places. Okay, the silver is displaced by the aluminium. It pushes it out the way. And so what we end up with is AlNO3, but we need to make this balance. Aluminium has a charge of +3, nitrate has a charge of -1, so that means I'm going to need 3 lots of nitrate. And now that we know that our green metal aluminium has displaced silver, we are going to end up with silver metal, Ag. And so what I'm now going to do right up the top, I'll get to the question in just a second, we fill this in. So what is formed in this reaction? Number 1, we end up with aluminium nitrate plus silver metal. So what this shows us here is displacement reactions in practice. Will there always be an answer? No. However, if there is no reaction, I still need you to write no reaction. If you get into a test and you use the standard reduction table to find that there was no reaction, you must write no reaction. I don't need or want to see a formula in that case. I just want to see no reaction. There was a question up the back and then the other question.
How do you know if you need to balance it or not?
How do you need to know if you need to balance it? Well, this then becomes, we finish writing our equation, which is our word equation, step 1. We've written the chemical equation, step 2. And what we now have to do is actually to balance these 3. We always balance now. So you know what? Let's get into the practice of it. So I'm going to use a purple pen just to underline. So I've got 1 lead on the left. I've got 1 lead on the right. Is lead balanced? Yes. I have, 2 nitrates over here. I shouldn't balance nitrate. I should balance the nitrogen and the oxygen. But because it's always grouped together in this case, we can see it balanced over here as well. And then I can lastly check that I've got 1 zinc and 1 zinc. Is this all balanced? Yep, happy. Tick. Okay. My second one, because there's no reaction, I've no equation. So do I need to balance anything? No. And I get full marks anyway. The third one, however, is where we get a little bit interesting. And the reason that we're going to get a little bit interesting is we've noticed that silver and aluminium have a different charge. And that means the amount of nitrate to balance it is going to change a little bit. So when we have a look, we can see nitrate on the left. So 1 N versus 3 N's. 3 oxygens versus 9 oxygens. So what do I need to put right out the front of silver nitrate? I need to put a big 3. And this balances my nitrates. I now have a look and my silver, I have 3 silver on the left, but I only have 1 on the right. So what do I need to do to the silver on the right? I need to write a big 3. And that has now balanced this equation. Yeah.
Do you have to split it up so like nitrogen is balanced and oxygen
You
is
do,
balanced?
you do. However, in this case, we can be a little bit cheeky and we can just jump straight to the nitrate because we know the nitrogen and the oxygen are still bound as a nitrate. So we can see what's on the left is going to be the same on the right. It's not like it's been split across like water and hydrogen gas, for instance.
Yeah, so for like this, in the test, we can just...
For these ones, yes. It's good practice. I'm speeding through it right now, but it is still good practice to balance nitrogen and oxygen separately in this instance. Yes, final question.
Do we always have to say like silver metal, or can we just say silver?
I would like to see you state the metal followed by the word metal, please, just to make it very clear in your word equation what is taking place.
Do we get marks off if we do it?
Just state it, okay? Cover all bases. It's 5 letters and it shouldn't take you any extra time. Yes?
And then the next one just says magnesium, not magnesium metal. But
Assume it said metal, okay? Same with silver, calcium, lead. What do we notice about all of these ones? We notice that it's just a metal by itself, so that indicates to us that it is just going to be a metal, as opposed to something like sodium chloride, where we have the metal in addition to an anion, okay? Yes?
If you had like hydrochloric acid plus a metal,
Mm-hmm.
do you do the same thing but it's
Somewhat, yeah. So what we'll have a look at in a second is acid and metal predictions, okay? So what's going to happen in these ones here, okay? So I'll pause right now and we'll come. All right, so to finish off our final little bit here, let's look at acids and metals now. So to help us out, and I need you to pay attention to this part here, so just following along with me, when we have sulfuric acid, we know the formula from our past lessons is H2SO4. And when sulfuric acid gets dissolved in water, it splits into the positive cations and the negative anions. So we end up with 2 hydrogen and 1 SO4. Okay. The next reaction is hydrochloric acid, and we can see, maybe I'll split it up by color now, we can see 1 hydrogen ion, and it's also going to form 1 chloride ion in solution. When we look at nitric acid, again, there's 1 hydrogen, and there is 1 nitrate, okay? And so this one is going to become, if we write it out here, 1 H plus and 1 NO3 minus. When we move down, ethanoic acid. Ethanoic acid is CH3COOH, and when dissolved in water, it becomes 1 H plus 1 hydrogen ion and 1 ethanoate, so CH3COO minus ion. The hydrogen always come first? It can, sure. Okay. In phosphoric acid, we have H3PO4. And when we talk about H3PO4, it's going to break up in water, and it's going to break up into 3 hydrogen ions and 1 phosphate ion. Now, what do all of these share in common? What do they all share in common when they dissociate in water? Any ideas? They all share one element, which is hydrogen. And so the name of the ion found in all acids when they're dissolved in water is hydrogen. Notice how I'm putting this in bold, and I'm going to, I'm going to circle it as well. Well, no, I'm not going to tell you what's in the test, but all I'm going to say is this is really important for you to understand our next part here. So, using your standard reduction table once again. Remember how hydrogen was highlighted earlier? This is when we use it now. We use hydrogen in the place of an ion in acids. So when we have an acid plus a metal, we can figure out if a reaction is going to take place. So in the case of ethanoic acid, what I'm really asking here is, will silver metal react with hydrogen ions? And look, it's very simple here. We're just going to see if a reaction occurs. So we go to our standard reduction table, silver metal and hydrogen ions. So let's jump over. The first one that we have a look for is silver metal, which is right up the top on the right-hand side, and we look for hydrogen ions. And we see hydrogen ions on the left, just below. Because the left is below the right, there is going to be no reaction. And so what you're going to write in this box here is going to be no, because there is no reaction. When we then look at nitric acid and zinc metal, what is the ion that we're going to use to represent nitric acid on our standard reduction table? Hydrogen. So we're looking for hydrogen ion and zinc metal. So again, I'll jump back to my standard reduction table. Hydrogen ion and zinc, apologies. I'll get to the question in just a second. Zinc metal, hydrogen ion. We can see the left hand is above the right, and this means that in this instance, there will be a reaction. So for this one here, yes. Now, what we're going to do is I'm going to scroll down a little bit here, and I'm going to write 2 equations. You know what? We're just going to write one in the interest of time. And the equation that we're going to write is going to be for number 2. So I'm going to start. Nitric acid plus zinc metal produces something that we'll talk about in a second. And so when we're having a look, we know that the formula for nitric acid is HNO3, zinc metal is Zn, and we've been told that a reaction takes place. This is still a displacement reaction. So what is going to switch positions with zinc in this case? Zinc is in one color. What is it going to switch places with? hydrogen. Very good. And so when we rewrite this one over here, it is going to produce, sorry, I'll use my blue pen. It is going to produce zinc nitrate. What's the charge on zinc? +2. So I need to put 2 brackets around my nitrate like that to make sure everything equals 0. And what am I going to be left with on the side of this reaction? Hydrogen. Now, hydrogens, we've had it as an ion previously, and hydrogen, when it's not as an ion, is going to be in the form of H2, which is hydrogen gas. Okay? So this is going back to our formulas for acid and metal produces salt and hydrogen gas. So our salt in this case is zinc nitrate. And the hydrogen gas in this case is still exactly the same. Now, the only thing that we need to do to make this balanced is we need to check the number of hydrogen and nitrate on each side. And to simply balance it for us this time, and just in the interest of time, we just put a 2 out the front of nitric acid. So what I'm going to ask you to do now is, can you have a go at those final ones there? Okay. Now, we can use the standard reduction table and hydrogen to also help us out with reactions with water and air, but the one that I'm going to get you to practice right now is just acid and metal.